Hi everyone, I'm Lewis. I work for Crosslake on Mojaloop, and I'm joined by JJ from Google. Oh, there we go. There he is. And we're going to be presenting some updates from the PISP workstream. So, this is what we're talking about. Bit of background. I'm going to skip through these. We've talked about them before. Basically, in one sentence or maybe two sentences, PISP is a new type of participant within Mojaloop, and it has no liquidity. But what it does is initiates transactions on the behalf of users. So a user can use a PISP to link with their DFSP and make transactions on their behalf. This is kind of the working model for UPI in India, and it's something that a few people in the community have seen and said, we want that for Mojaloop. So that's what we're building. Before I talk more about that, actually, I think Adrian's here with us as well, because since we've been working on the PISP workstream, what's emerged is essentially a new set of APIs within Mojaloop called the third-party APIs. And it's what we've kind of seen is, as we proposed a bunch of APIs for the PISP use cases, other people have jumped in and said, oh, wow, actually, that is more useful for us, or that is something that we could, we could tweak it in this way and see how it works for this use case. So, Adrian, if you're with us, would you like to just give us a bit of an overview on the third-party APIs and how you see them working?
Sure. Thanks, Lewis. So, stealing a bit of the hard work that's been done by the folks in the PISP work stream, we spotted sort of a pattern here that we could leverage. And this was coming from the work we had previously done on the legacy payment system integration. So you may recall quite a while back, we wrote an integration to do ATM and point of sale transactions. And when we re-looked at those flows through the eyes of connecting to the Mojaloop hub using third-party APIs instead of DFSP APIs, suddenly the deployment scenario seemed way more sensible. We had sort of assumed that our adapter would be run by a DFSP or by the hub, but actually a lot of use cases like PISP make a lot of sense if the entity connecting to the hub is doing so through a new set of APIs specifically for third parties. So we've been diving into that a little more deeply. I'll talk a little bit about the ATM POS and cross-network use cases tomorrow. I know Michael and Moses have some plans to talk about split payments and also bill payments. But Lewis and co will talk about PISP. But I think it's a very exciting development. We mentioned it in the product management work stream or presentation on Monday as well, or Tuesday, sorry, with Leslie Ann. And I think a really interesting differentiator for Mojaloop. So anyone who is interested in exploring those a bit more, there's a bunch of use cases, and we're excited for some of the others to follow behind PISP and leverage some of the great work that guys have done already.
Cool. Thank you, Adrian. So yeah, without further ado, let's jump into our update from PI 11. So yeah, these were the 5 objectives that we set out to achieve in PI 11. The first one, end-to-end transfers, actually carried over from the previous PI because it was a lot more work than we thought. It tends to happen sometimes. So this is the current kind of status of where everything is. The only one we can't really tick off completely is the auth service implementation. One of our trusty interns discovered some tweaks that we need to make to the API and the signing process, or the registration process to really consider that done. So yeah, let's just walk through these. JJ, feel free to jump in if you've got anything to add. Otherwise, I can kind of just keep on.
Yeah, keep on going. This sounds great.
Jabbering on. So yeah, end-to-end transfer flow. This was really, if we remember previous kind of talks, we had 2 flows, or even Victor mentioned it earlier. There's the linking flow, which is setting up the trust between a PISP, a user, and the DFSP. And the transfers flow is actually initiating the transfer. We've decided to tackle transfers first. Basically, we can say that we've got end-to-end transfers working pretty much. There's a few, in terms of the implementation of the switch, that is complete and we're happy with that. it's kind of the stuff on the edges around the scheme adapters and the simulators that needs a little bit more work. We've got CI/CD pipelines, we've got everything built, we've got an awesome Docker Compose environment. We've got also a kind of a demo lab environment for testing against a live switch, which is like a simplified version of our current Helm charts. And like I said, the scheme adapters and the simulator it's completed. We're calling it POC. It's not really quite ready yet for public consumption. Auth servers, so we need to update the API to cater for the FIDO attestation options. There's a few changes that we need to make there. And we also need to clarify the signing of the initial kind of setup process. Step 4, account linking flow at the switch. So this was kind of our core implementation of the account linking flow. And this is implemented with the testing toolkit being used to mock out the DFSP side. There's a few other changes we've made to improve kind of the flows. One of them being a proposal to use the ALS to store this consent object. The consent object is like a representation of that trust between those three parties. So we want to include that into our future design so that we can open up further API calls in the future, such as like a get consents, and we're using like a single identifier for consent. We can figure out who the DFSP is, who the PISP, and who the auth service is. So, and finally, this was a little bit of a stretch goal because this was assigned to interns, and we've got a working MojoPay demo app. And once again, working should have an asterisk here. It's heavily mocked out, but I think you'll be excited when you see what we've got. So in the past, we've kind of talked about the API calls that needed to be implemented. So this was this is an overview of all of those API calls. So it's kind of laid out so that we have the left side is the simulator and the scheme adapters. Oh, I'm so bad at drawing. The middle bit is what the actual implementation of the switch is. Also bad at drawing. And then the right side is like the receiving of those and handling like the inbound requests. So let's clear that. So yeah, this is what we said we'd get done. This is where we're at the end of PI 10, so in 3 months ago. And this is where we're at now, which is all green, all complete. We've got this implemented. This doesn't kind of cover all of the linking between those calls and stuff, but in terms of handling API calls, we've got that going. As for the linking, this is what it looks like. This is where we're at PI 10. This is at the last PI. This is where we said we wanted to be for the end of well, today, and this is where we're at. So we're looking good. I think we've made some really good progress, and yeah, thanks to the hard work of all the PISP team to getting us to this place. So in terms of, there's a couple other design questions and issues that we do need to address. The two main ones to talk about is the transfer signing problem. JJ, would you like to take this one, or I'm happy to take it?
Sure. So the basic idea here is we had to figure out, since FIDO is being used not just for authentication to prove that you have a specific private key, but for an explicit authorization saying, I also am acknowledging that I've seen this transaction, I am happy with it, and I am willing to follow through with it. We're combining those two into one signature by using, instead of the FIDO spec, which calls for a random challenge just to prove authentication, we're using a meaningful challenge. And for this, we had a lot of back and forth and debate because we need to make sure that the thing we're signing is meaningful and contains all of the information and details that are absolutely necessary to, after the fact, look back on a transaction. And even when there is doubt about whether somebody tried to fake something, we need to be able to easily and quickly prove, no, like you're the only one with this private key and you signed this exact set of details. Here, go try it for yourself and reassure yourself that this is correct. Here was the signature that we have on file. And so we had quite a bit of debate here. The good news is If we're looking at the API version 2, then we have something that's very simple and straightforward to sign. If it's version 1.1, which is kind of what we were thinking we would be using here, but there was a little bit of debate because some of our earlier stuff actually did rely on V2. But in that case, we think that right now we can use the ILP packets data payload, which is just sort of a base64 serialized JSON object containing all the information about the payer, payee, amount of transaction, and things like that. And obviously we need to hash it because the signature ability on the Android and iOS devices has a limit to how much data you can pass in. So the idea was that we need to make sure to hash everything before passing it along. Since we don't actually get access to the private key, we just use a special API that says, hey, can you please sign this with that private key? And I see Miller asked about whether it includes a nonce or other random data. I believe that the transaction ID was what we were considering to be random enough. I think that there's more debate to be had there, but this is our current discussion that we have ongoing. Lewis, you want to take over from here?
Yeah, sure. And the other kind of secondary problem here, and we've been going around a little bit on this one, was getting the callback. Once a transfer is complete, how do we get the notification back to the PISP at the end of the transfer? We've had a few guiding principles on this, thanks to kind of Miller and Michael and some of the other people for their input here. A few of them was that we want that notification to come from the switch, because the switch really at the end of the day is the final authority on when a transfer is complete. We also don't want to store any separate state or anything inside of the switch. We want the switch to be able to derive who it should inform at the end of a transfer based on the messaging, based on the contents of the messages alone. So our current proposal, which would require V2 of the FSP OP API, would be adding this object like a subscribers object, or a list, I should say, to the transaction object. And essentially what a DFSP could do is, when it is initiating a transaction on behalf of a PISP, it could add the PISP to the subscribers list in the transaction object. And during the quotes callback from the payee DFSP, that's when that subscriber list would be finalized. So yeah, I mean, this is, we're still thinking about this. I know I owe Henrik and the CCB guys an update and a more detailed proposal. So we're getting to that. But yeah, other thoughts and input would be definitely appreciated here. As much as possible, we don't want to have to rely on the next kind of version of the FSP OP API. So yeah, if we can do it otherwise. Anyway, it's in discussion. We can just leave it there and follow up the discussion in the discourse for sure. So thank you, Miller. I see that point. I think we are short of time, so I think we'll follow up in discourse and on and elsewhere on. I think we have some GitHub issues as well. So in terms of some of the outputs, I think we're gonna have to skip over this one, JJ, if that's okay, time-wise.
Yes, absolutely. Please, let's skip this.
Cool.
Given our...
So yeah, we've got a couple really cool demos to show you guys. The first thing we should just consider is the iceberg, and think about what I'm showing you here is really just the tip of the iceberg. And for me, it's not even the interesting part. It means the nice paint that goes on top of all the interesting parts of the hard work of the PISP team. So I'm going to be showing both the account linking flows and the transfers flows. And so for our account linking, we're using the testing toolkit, and I'll be going into this demo a little bit further in the testing toolkit update. But essentially, we have a few things going on. We've got the testing toolkit, which is pretending to be the switch and the DFSP. And then we have all locally running on my device is both an Android emulator and this PISP demo server, which our interns wrote. And then we have this Cloud Firestore database, which is like an event-driven NoSQL database, which we're using to synchronize between the Android app and the demo server. So let me just switch over to demo mode, and we can go from there. So just bear with me a second. So this is a live demo, which makes me nervous. Or let me try that again without ticking that special box, just to make the internet faster. All right. So let's see. Did I appease the demo gods? They're very, very touchy. Okay, so on the right-hand side, we can see the testing toolkit. The left-hand side, we can see our Android device, and we can open up. Oh, there we go. That's already off to a good start. Let's just close and reopen that one. I'll blame the interns. So yeah, this is our kind of Mojapay demo app, which is an example, a reference implementation, or a working reference implementation of the PISP work. So from our homepage, we can link a new account. And then that comes up with a list that was pre-populated of the DFSPs that our user can link with. So in this case, let's pick DFSP A, because that's who I hold an account with in this example. At this point, you can kind of, our design allows for someone to enter in an opaque identifier. So it could be, it's kind of like whatever you use to log in with that DFSP, let us know what it is. It can be an email address, it could be a phone number, it could be anything. So let's use my email address, because let's not use my personal email address. Let's just say I use lewis@example.com to sign up to DFSPA. So now we can see that get parties call is coming through to the testing toolkit. And then we can select which accounts we would like to link with. So there's 2 accounts, both in US dollars, which came up when we did the get parties call. And I can either select one or both of them. I guess I could select none if I wanted, but that would be silly. So now there's 2, if we remember our PISP talks earlier, there was kind of 2 ways to log in. One, we accounted in our design for a web-based authentication, where we would get, at this point, redirected to the DFSP's website to do a login. The other option, which we've designed for, is OTP-based. So we're using OTP here just because it's a bit easier to demo. So in the real life world, what we'd expect, it would be a notification from my bank or my mobile money wallet to say, hey, Mojapay is trying to link your account. Provide them with this OTP in order to proceed. So we're going to use the OTP 121222. And let's log into our account. So behind the scenes, our PISP is creating this consent request object with that OTP result contained in it. And then the reply from the DFSP, sorry, is a request called a post consent. So let me see if I can expand. So okay, we actually don't see it here because we're using some backdoor tools of the testing toolkit that don't show up here. But behind the scenes, there's this post consent object that gets created, and now we have to link our fingerprint with that consent object. So this is where we're registering a FIDO key. So in a demo, we're not doing any FIDO calls. We're just doing a simple example. But we do have a FIDO library that one of our interns has written to enable us to do this in the future. Very, very gracious of him. So I can touch the sensor using the simulator, and now we are linked. And now back to the red screen. So that's the account linking flow. Let me go back to my slides briefly. So that is a very simplified version. So we're not actually talking to the switch. We're talking to the testing toolkit, which is pretending to be the switch. Now, this is the fun one because, oh, there it is. It's an end-to-end transaction. So in this example, like I said, we have the end-to-end test, end-to-end transfers working. This time we're doing the same thing on the left, but we're actually talking to a live version of the Mojaloop switch, which has the PISP modifications, and we have a couple simulators. Now, like I said earlier, there's a bit of glue and duct tape holding this together behind the scenes, but we're getting very close to having a very viable end-to-end test. So let me now, I pre-recorded this video, so let me go ahead and share the video. I didn't trust myself enough to do 2 live demos in one day. That would just be crazy. So optimize screen, and I'll just hit share. Can someone just let me know if you can see that, JJ? You got the...
Yep, you look good.
All right, thank you. So similar thing, we're launching the application. This time we're going to go to the transfers screen. So here we go. And we can enter in a phone number of the person that we want to receive the funds. So in this case, it's someone in India with an odd looking number. And we've done, I'll just pause it there actually. We've done a party lookup behind the scenes. We found Alice Alpaca. Thanks, Kevin, for that demo name, very nice. And then now we can enter in how much we want them to receive. So $18 US in this example. And then we can go ahead and initiate the third-party transaction request is what's happening here. So I'll just pause it again. So what's happening behind the scenes between those 2 screens is we've sent the request to the DFSP, and then they've said, all good, this looks fine to me. You know, I know this consent ID you've registered earlier. This person has funds available in their account. Then they went behind the scenes and did a quote request between their themselves, their DFSP, and Alice Alpaca's DFSP. And that quote response came back, and then they sent that back to the PISP to go and confirm with their user, and then to sign the transaction using their FIDO private key. So that's what's happening here. They're signing the transaction, and then the transaction was successful. So like I said, there's still a bit of duct tape kind of holding that together behind the scenes, but hopefully you get a feel for the hard work that everyone's been doing here. And so we've got the videos as well there. How are we doing for time, Simeon? I think we're just about done here.
You have 10 minutes to go, so.
Okay, all right, cool. All right, well, I'll spend just a couple more minutes here. We had some really other cool outputs. I've called them out before, but I'm just excited about them, so I'm going to share them again. So as part of the PISP workstream, we've got other stuff that we'd love to share with the broader Mojaloop community and elsewhere in our code base. So we've got automated CI/CD releases with auto-generated changelogs and release notes. So this is an example of an auto-generated release. And this took 0 work to actually to create these release notes and do these releases. And the build numbers are incremented, or the semantic version is incremented based on the pull requests that are made. We've got a Docker local Mojaloop switch for local development. So that's a Docker compose file with a bunch of other stuff that runs a full Mojaloop switch. So that has been really useful for us for doing our CI/CD tests and kind of getting our local environments up and running. I know that some of the guys at Coil have used this as well, or at least they've told me, or I've gotten them started with it. So I'm hoping that we can keep developing that and find a way to share that more broadly. I think that really touches on Adrian's point, I think from Monday, or it was yesterday, about reducing the debug loop time. If you've got Docker Compose running locally, it means you could actually rebuild your images really fast and make changes really fast and see kind of see bugs being fixed, or your debug loop gets really small. You don't need to use Kubernetes. You don't need to upload images and download them and all of that stuff. We've got a POC method for seeding test environments. This might have been superseded by the testing toolkit, so that's why it's still POC. And finally, we've got API snippets, which is a repository where we share Swagger file snippets and keep them all in one place. And that means in order to write Swagger files, they've gone from being thousands of lines, or maybe 1,000 lines long, to 200 200 lines long, and they reference these common snippets. So not only does it make writing these APIs easier, it means that our different services which have Swagger files or open API files, as they're known as now, it makes them more consistent across all parts of Mojaloop. And one of the real critical things with doing microservices is making sure our interfaces are consistent. If your interfaces are the way that microservices work, and if they're not any good, then you're in a lot of trouble. So let's talk just for a second about the future. We've got some ideas for the PI12 roadmap. Like I said, we've got those API changes that we want to make, and there's a few discussions going on there. We want to finalize the linking flows and do what we've done for the transfers flows in the scheme adapter. We want the lab to be more kind of fully featured in self-service. And then finally, as Sam mentioned earlier on in the day, we need a pathway to merge back in upstream to Mojaloop. So for a few of the services, they're standalone, they're PISP only services. Others, we've had to make adjustments and changes. And so we want a pathway to merge those things in so that we can essentially one day say, okay, would you like to deploy PISP features on Mojaloop? Please flick the switch, and there you go, PISP stuff is enabled. So that also includes test scenarios, very, very important as well. So please give us your thoughts and your feedback and your input. And finally, kind of looking further afield, although we don't need to wait 3 months to start doing this. Some of the other things that I just thought about today as I was reflecting on this was refining the demo app as a real nice, proper reference implementation. Treat some of our documentation outputs as a product, especially if we're thinking of the third party as a way to engage fintechs, or the third-party APIs as a way to engage fintechs. That means our potential audience for this stuff is a lot bigger than big DFSPs. So yeah, that's just something that's been on my mind, and we want to keep our finger on the pulse with. And then also, like, I think it's really important to engage with fintechs and get them excited about this stuff now. Already we've got Snap, who's building the split payment stuff. So who else can we talk to? Who else can we get excited about this? And what else might we need to tweak to make this a use case that's viable for your business? So, JJ, is there anything else you'd like to add? Other than that, I think we're just about there. Cool. All right. I'll throw open to some questions if we have some time. Otherwise, we can move straight on to the next one.